Welcome back to our APES flipped classroom for our final biogeochemical cycle discussion. And this is all about the hydrologic cycle or the water cycle. And this should be a very familiar cycle. We've been learning about the cycle probably since second grade, but it's good to have a quick review. So we know that this cycle has lots of different stages. We have evaporation, where surface water evaporates, and as it rises and cools, it condenses and forms clouds. When those clouds get heavy enough, contain enough water, then we have precipitation, and that forms eventually runoff or infiltration. So if we have infiltration, that means it penetrates into the ground and infiltrates our groundwater. If it forms runoff, it goes back into the surface water, and we start the cycle over again with evaporation. We also have a few little mini processes within the water cycle. So we have uptake by plants, and then what we call transpiration, and we'll talk a little bit about that one as well. So water cycle, just like all of our other cycles that we've talked about, is the movement of water in different forms through different sources and sinks. The key to the water cycle, of course, is that the state of matter is also changing as we move through the water cycle. Just as the nitrogen was in different forms and the phosphorus was in different forms, and even the carbon is in different forms. In water, it's all the same chemical formula, but the state of matter is changing. So our precipitation is taking us from a gaseous form into a liquid form that is landing on the land or in the surface water. Our water cycle is driven by energy from the sun. So the warmer the atmosphere, the more evaporation we're going to have, and therefore more condensation and more precipitation. The largest water reservoir is the ocean. There is a small and relatively consistent amount of water in the atmosphere, but the ocean is by far the largest water reservoir. We also have ice caps, groundwater, surface water. Those are much smaller reservoirs. Ice caps and groundwater contain fresh, usable water for humans. So let's talk a little bit about where the water is, what those reservoirs are. So if we were to look at all of the Earth's water, total global water, 96.5% of the water is in oceans. There is some saline groundwater, a little bit less than 1%. There is a tiny fraction in saline or salt lakes. And then the rest of it is made up by fresh water. Only 2.5% of the water is fresh water. Of that 2.5%, most of that, 70%, nearly 68.6%, is trapped in glaciers and ice caps. 30% of it is in groundwater. And then if we were to look at the surface water and other fresh water, which is only 1.3% of the fresh water, remember the fresh water is only 2.5% of the total global water, only 1.3% of that is surface water. And if we're to look at the surface water, 73% of that is in the form of ice and snow, 20% in lakes, and the rest in soil, swamps, marshes, rivers, and a little tiny bit of atmospheric water. So we can see that although there is a lot of water on Earth, very little of it is usable by us and by plants because we can only use fresh liquid water. Okay, so back to that cycle. So there are two main sources or main processes that cycle water from liquid on Earth back into the atmosphere, and those are evaporation and evapotranspiration. So evaporation is one that's very familiar to you probably. This is the one that's sometimes called vaporization. Liquid water becomes water vapor in the atmosphere. And so that's evaporation. That's just driven by heat, by sunlight. We also have transpiration, which is the process that plants use to draw the groundwater from their roots up to their leaves. And in transpiration, the leaves open the stomata, and that allows water to evaporate from the leaves into the atmosphere. And that creates essentially a vacuum. That movement of water out of the leaf creates low water potential in the leaf, and through osmotic processes that pulls the water up from the roots. So when we talk about evapotranspiration, we're talking about the water that enters the atmosphere from transpiration and evaporation combined. And there are areas where this is a huge amount of water. We talk about the river of the airborne river above the Amazon rainforest, because there is so much water entering the atmosphere through evapotranspiration. Both of these processes, evaporation and transpiration, are driven by energy from the sun. So that's how water enters the atmosphere. Now we're going to talk about the other side, where water is precipitating from the atmosphere, and it is either running off into a body, off the Earth's surface into a body of water, or trickling down through the soil into groundwater aquifers. And we call that process infiltration. So we have precipitation, which leads to either runoff or infiltration. Groundwater and surface waters are both important freshwater reservoirs for humans and for animals. Groundwater can be recharged by precipitation, but only if the ground is permeable, meaning that it's able to allow water to pass through. Really parched land and really hard land are not nearly as permeable. So runoff recharges those surface waters, but if the area that it's running over, it has pollutants on it, it can also carry pollutants into the water sources. So you can see in our image here that we have topsoil and plants, and that actually improves the ability of soil to be infiltrated. When we have really dry land, water tends to run off instead of actually recharging. Okay, let's talk a little bit about groundwater. So when it does infiltrate, then we call that groundwater. So the top layer of the earth is above what we call the water table, and water that infiltrates into here is available to roots and can be uptaken by our plants. And that's an unsaturated zone. That soil is not saturated with water. Below the water table, the ground is saturated with water. This is the area where we find aquifers. There are different types of aquifers. We have confined aquifers and unconfined aquifers. Both are going to be saturated with water. An unconfined aquifer has a permeable water table, and a confined aquifer is bounded above and below by a less permeable layer, whether that's clay or rock. Confined aquifers create what we call artesian wells. So that's if you drill a well down into a confined aquifer, that water is usually under pressure. So it'll actually come up without the assistance of a pump. Okay, so that's our water cycle. We have evaporation, we have evapotranspiration from plants and the surface of the earth. We have runoff leading into the ocean. So we have more evaporation, condensation, precipitation, and then that leads again to runoff and infiltration and back around to the evaporation piece of the cycle. As always, if you have questions, please write them down, let me know, and I look forward to seeing you soon.